In this video, we will begin to discuss quadratic graphs. To introduce quadratic graphs, we will talk about the term parabola because the shape that is created by a quadratic equation is called a parabola. There are a lot of different real-world situations that make the arc shape of a parabola when modeled on a graph. So for example, if I use something called projectile motion, if you sort of picture somebody hitting a ball upward or shooting a cannon upward or something like that, then you get this shape where the projectile goes up, makes a little arc, and then comes back down and lands. This is called projectile motion. And it creates a quadratic equation when we write it out as an equation. We also see this happen when we have a profit model. We talk about this a little bit on page 548 and 547 in your book. So this is a good thing to pause and go watch the video for. One of the things that happens when you produce items is that there's sort of this ideal number of items to maximize the profit. And so if I make just the right number of items, then I'm making the most profit because I'm able to sell them without reducing the price and without losing money other ways. So we'll find that there is an ideal number of items and we can model profit using, again, a quadratic equation. Now, when we're taking a look at pages 548 through 550, which is where I'd like you to go next, if you turn to pages 548 and 550, then you'll have already passed the beginning of the section where you're taking a look at some common arc shapes. And we'll be focusing on building a play area for a dog called Moose. And this will really walk you through the process of one approach of finding a quadratic equation to model a situation. I highly recommend you work through this entire process, and you will definitely want to watch the videos to check yourself, particularly as you get to questions 8, 9, and 10. The did you get it in number 2 will do a nice job of reinforcing. So at this time, go ahead and pause this video and take a look at your book and work through all those problems in your book. Okay, now that you've worked through those problems in the book, it's useful to talk about some key points on a parabolic graph, in other words, on a parabola. So let's take a look at the following graphs. On each of the following graphs, I'm going to mark the x-intercepts to begin. Now, on the first graph, there is no x-intercept because remember, you can find the x-intercept by looking at where does my function cross the x-axis. Well, my first function never crosses the x-axis, so it doesn't have an x-intercept. My x-axis for this function is right here. So my function crosses the x-axis at these two values. And my x-axis for this function is here. So I have x-intercepts I have a single x-intercept at that value right there. So in this first case, I have no x-intercepts. In this case, I have 2 x-intercepts. And in this case, I have 1 x-intercept. Okay, the next value that I want to identify are the y-intercepts. The y-intercepts are the value or values where my equation crosses the y-axis. Let me use a different color here. So the blue line is the y-axis for each of these. And you'll notice that each of these functions has 1 y-intercept. And that's the dot that's in blue. And the next topic will be to discuss the vertex. So we need a definition to understand the vertex. The vertex is the point at which the parabola changes to a direction. So if it was going up, then it starts coming down. If it was going down, then it starts coming up. And these create maximum or minimum values. So the vertex for this first parabola is this dot in green. And this is the vertex for the second graph, and this is the vertex for the third graph. So I'm going to label this the vertex, label this the vertex, and I'm going to label this the vertex. And I want to point out that for that last graph, the vertex is also the x-intercept, which is not always true, but it is true in this particular picture. So on a graph, one of the things I'd like you to be able to do is find and interpret the meaning of key points on the graph. And really taking the time to go through these parts in the book will be key, because interpreting the meaning is a really important part of what we're doing here. And the book does it so well that I do not go through it in the video. But I'd like you to go and take your time going through and understanding, what does the y-intercept mean for a certain situation? What does the vertex mean? And I'll give you an example when it comes to projectile motion of what we mean here. So if I have a graph that represents projectile motion, then if I want to label the y-intercept, it would be right here. The vertex would be this point up here, and the x-intercept would be this point here. There would also be an x-intercept back here if we extended the function. So to talk about the meaning of each of these in the context of projectile motion, let's suppose it's a baseball player hitting a ball. And let's call this the horizontal distance. And let's call this the height of the ball. Okay, let's go through one at a time and discuss the meaning of each of these. This blue y-intercept right here is going to represent the initial height during the time where the ball is hit. So right at the beginning, you don't hit it off the ground, you're hitting it out of the air. So that's the initial height. The vertex represents the maximum. Well, we can think of it as the maximum height, or you can think of it as like the peak of the ball. And remember, the vertex is an ordered pair with an x value and a y value. The x value will represent the horizontal distance when the ball peaks, and the y value will represent the actual height when the ball peaks. And finally, this red dot over here, which is the x-intercept, is going to represent the horizontal distance when the ball lands. So we can find out information about a situation like projectile motion by looking at these key points on the graph. And we don't do a ton of different situations. So as you go through enough examples, I think you'll get the sense, if you're very familiar with the examples, of what each of the key values means. So please make sure you take the time to go through the bookwork as well.